We are the students of Veltech Multitech Dr. Rangarajan, Dr. Shakuntala Engineering College from the Department of Electronics and Communication Engineering are here to present our project on the topic of prediction of colorectal cancer using efficient net neural network. Myself, M. Priyadashni, and my team members are Devdashni and Durga, and we are guided by our Professor Muhammad Abbas sir. Coming to the objectives of our project, main objective is to develop an automated system that can potentially reduce the pathologist's burden by functioning as a screening device and to predict the likelihood of an individual having colorectal cancer using efficient net V2 pre-trained network to improve the processing time and accuracy of the prediction. Introduction. Coming to the introduction part, colorectal cancer is the third most common cancer diagnosed worldwide across many countries. Most of the men and women are affected by colorectal cancer. So this is the most common type of cancer, and the main risk factor of this cancer and the main cause is obesity. The main cause for the colorectal cancer is obesity, which is due to over intake of junk foods. Generally, the development stage of colorectal cancer involves three stages, that is initiation, promotion and progression, and these tumor cells are examined by hematoxylin and eosin pathology. So these in which we have worked on for a literature review for our project. Next part is the types of tissues. Here we are taking 9 types of tissues from the colorectal cancer, namely adipose, background debris, lymphocytes, mucus, smooth muscles, normal colon mucosa, cancer associated stroma, colorectal adenocarcinoma, epithelium. So these are the images of these 9 types of tissues. Actually these are digitized images of H&E stained images from the pathologist. Coming to the block diagram of a project, first step is the input data set. We have collected a input data set from the H&E stained images from the pathologist. Then the next step is pre-processing, where the images in the data set are pre-processed. Then we are using a pre-trained network model called efficient net V2 neural network. There all these images are trained. Finally, after training, the results are validated, and the step is finally the cancer is predicted based on the types of tissues. So here is the content about efficient net V2. So this is the currently using network most widely used. Why we are going for this network is it is the generally faster to train than other CNN models. Actually efficient net V2 comes from the success of efficient net previous model, and it is a faster network. Here efficient net V2 uses MB convolution and fused NB convolution, which is responsible for more training speed and parameter efficiency. The training process. Actually the image data set consists of 7180 histological images of human colorectal cancers as well as healthy tissues. The original data set images are first converted from the TIF files to JPG files. By doing this conversion from TIF files to JPG files, the resolution and the size of the image stays unremained, okay, but the actual image space says if the image space is 120 KB, then it is likely reduced to 8 KB. That is, from 120 KB, the image size is reduced to 8 KB, but the resolution and the dimension of the image remains unchanged. Then the data set is splitted into two parts, that is training and testing. For training, we are using 80% of the data set images, and for testing we are using 20% of the images. This split option is done by split underscore master dot py command. So here are some of the converted images from TIF to JPG files shown here. So these are some of the examples. Next, as I said, this is the distribution of a image set. For training, we have used 80% of the images. For testing, it is 20% of the images. It shows the distribution of each class of images. Next, so after the training process, it gives us the two training results, that is training accuracy and training loss. Here we have shown the training accuracy of a model. We have used a learning rate of 0.0001, which has an accuracy of 0.99 out of 1. And next is the training loss, which is very low to 0.1 percentage. So the actual idea of a project is, first the flow is from first the images are trained, then the inference are obtained, then we are going for evaluation. So first we have completed the training process, next we are going to do testing. From that we will obtain an inference result. So these are some of the images, some of the test images, that is 20% of the images for testing, randomly selected images from each classes. After these images are subjected to testing, after testing the inference results are obtained. Here this CSV file shows the inference result, that is first the label, the labeled images is adipose, and our model has correctly predicted it as adipose tissue with a score of 0.931, and it also given a second prediction of stroma tissue with a lower accuracy of 0.173. So we can take that our model has correctly predicted the labeled image in the prediction 1. After inference, the inference results are evaluated in the evaluation process. Here in the evaluation process, the network compares both the actual output and the inference result and gives us the prediction whether it is correct or not. Here is the evaluation console output, which gives us those predictions with 4 parameters, that is F1 score, precision, recall and support, and it also generates a confusion matrix and a classification report, which we will see in later slides. So here are some performance metrics, as I said before, F1 score, precision, recall and support. So these are the main parameters calculated in the evaluation process. Coming to the F1 score, F1 score is a machine learning evaluation metric. It measures the model's accuracy, and it F1 score combines both the precision and the recall and gives us an output. Here the formula for F1 score is shown, that is, here precision measures how many of the positive predictions made by the model were correct. Okay, and this is the formula for prediction, that is true positive and false positive. It gives us the ratio of true positive to the true positive plus false positive scores. Next, coming to the recall. Recall measures how many of the positive class samples present in the data set were correctly identified by the model. So here is the formula for recall. It deals with the ratio of true positive to true positive plus false negative. Next, coming to support. Support gives us the number of occurrences of the class in the data set. As I said before, the evaluation command will also generate a classification report and a confusion matrix. So here is a classification report. It gives us scores of all those performance metric parameters as predicted, and it also gives us the final accuracy, macro average of the predicted scores and weighted average. Confusion matrix. Actually, a confusion matrix is a performance evaluation tool used in machine learning to assess the accuracy of a classification model. Some of the important terms used in the confusion matrix are true positive, false negative, false positive and true negative. With those parameters, it will shows us a confusion matrix of a prediction. Confusion matrix of a project, it shows us the prediction of matrix of actual to the predicted outcomes. Let us see the working of a project. As I said before, data sets are collected and efficient at V2 architecture in deep learning is used. So there are more Python files here, but we don't need to run all these files. Instead, we can use three main bat files which comprises of all these files. That is, there is no necessary to run all these files individually. The bat files automatically runs all the command as those files are already imported inside it. There are these are the three main bat files, that is train.bat, inference.bat and evaluate.bat. Now I am compiling the train.bat file. After the train bat file is compiled, the basic checkings are completed and it starts to compile the epochs one by one. So here each epoch has 479 images. It almost takes 1 hour to complete this process completely. So I am terminating it here. Now the model is trained with all the images. The next step is to check that whether the model is predicting the correct tissues. So this is done by using the inference.bat file. As soon as I started compiling the inference.bat files, here it gives us all these results, prediction results one by one. So after this process, finally the evaluation bat file is compiled and it checks that whether the model has predicted the correct output for the result from the inference bat file. The inference bat file gave us 1202 images. Now it is checking with all those images whether it has predicted correctly or not. After this prediction checking, finally this evaluation command will also generate us a classification report and a confusion matrix in the end of the evaluation. So this is a whole working model of a project.